Hello, everybody. Hope you're enjoying your snow day. So, because I won't be seeing you today, and actually for the A group, we were going to do something like this anyway, so this kind of works out. We'll be just doing these quick notes on measuring. Shouldn't take too long. So you want to start out by getting your Unit 3 packet and opening up to page 5. Okay, and once you do that, I want you to take a second and try to answer examples 1, 2, and 3. And then I want you to explain your reasoning down here at the bottom right. Okay, so once you have done that, hit the continue button, and I will walk you through what we should be doing. All right, so good job. When making a measurement, you record only digits that are significant. Okay, that's why we call these significant figures. You might also see them called sig figs, because we are lazy and we like to abbreviate things. Digits are significant if there are values that are known for certain. Right? An example of that might be like a number 1. We know for certain that this screwdriver goes past the 3 centimeter mark. Right? Plus the first digit that is estimated. Right? And I want you to underline, right, this first 3 times, because you can only estimate 1 digit. Okay? You cannot estimate more than 1 because you're only as good as the tool you are given. Right? So in example number 1, we can estimate 1 digit between 3 and 4. So 1 digit more specific would be our 10th place. Right? So we could maybe have something like 3.3 centimeters. So we'll get to that in a second. All right. So even though the last digit is guessed, it is still considered significant because we have a pretty good idea of what that digit is, right? We might not be as precise as we want to be, but it's a pretty safe assumption that we can break, right, break any of these spaces into about 10 individual spots for us to guess 1 more digit. All right, so let's go through what the correct answer should be here. So for example number 1, right, we know for certain it's at 3, right, and then we can estimate to about 3.3 or 1 more digit more specific. All right, next for example 2, right, which is the correct measure, right? We know for certain it's past the 20, right, and it goes up, right, almost halfway, and we'll talk about this little curvature here in a little bit. All right, so I can go 1 more digit more certain than 20, so that would get me to the ones place, right? This is counting up by tens, so I can go to the ones place. I get 23 milliliters, right? Don't forget your units. And lastly, for example 3, oh, there we go, our correct measure. So I can see, right, we're counting up by 1.1, 1.2, 1.3, 1.4, 1.5. We can see we're at about 1.6, but we need to estimate 1 more digit, right? So 1.62 meters would be the correct answer here. All right, so you might have noticed these things, this interval line that we did not fill out, right? So our interval, right, maybe we want to write this up above here. So maybe we write interval, right? And that is the, right, space between the smallest markings. It's a great time for my pen to die. Okay, the space between the smallest markings, right? So for example number 1, our interval would just be 1 centimeter because we're going up by 1 centimeter each time. For example number 2, our interval is going up by 10, right? And then we must attach a unit to that. We know our units are milliliters by our answers. Right? And example number 3, right? Why don't you take a second and write down what you think the interval is? Very good. So we are counting up our smallest markings by 0.1 meters, right? Even though the numbers are counting up by 1 meter, we're going by the smallest markings. So that's going to be 1/10 of a meter each time. Alrighty. All right, let's turn the page. All right, so now that you've got a quick little lesson here, all right, why don't you take a second, answer examples 4 and 5, and then why don't you also check out the question at the bottom. Don't forget to do the intervals as well. Okay. Alrighty, so let's check our work here. For example 4, I can see that my interval is going up by 1 centimeter. All right, our correct measure for this pencil, right, it is right on the 12, but we need to estimate one more digit specific, so it will be 12.0 centimeters. All right, and we're going to run into some issues when we have stuff right on the line, and we'll talk about that later. It's called the tricky zero. Okay. Example number 5. Right. So our interval is going up by the hundredths place, so 0.01 meters. Right. If we're counting up by 0.1 at our large markings, and we have 10 markings in between, then we must be counting up by 0.01. So this would be 1.30, 1.31, 1.32, 1.33, 1.34, 1.35, etc. So our correct measurement should have, right, 3 decimal places, right? If our intervals has 2 decimal places, so we should have 1.43, right? And if we draw this straight down, right, we have about 1.432 meters. Alrighty, so a good way to do this is if you see that if you get your interval first and you see how many digits it has, right? So this is going 2 decimal places. You're going to need to be one more specific, right? Or one more lower. So we need to get a 3rd decimal place in our reading, right? Up above, if our interval is going by the ones place, right? One more digit more specific or one more digit lower will be the 10th place, right? So we need to have a 10th place in our measurement. Alrighty. This one is a tricky one. Usually only about half of students get this one correct. So if you do, give yourself a pat on the back. So which of the following could have correctly measured an object to have a length of 12.3 centimeters? So we kind of have to think backwards here. So if we have 12.3 centimeters, right, that was our measurement. So we estimated the 10th place, which means that our interval must be going up by the ones place. So which one of these rulers are going up by the ones place? That would be B, right? And 12.3, right, would be about there. Maybe actually a little bit over to the right. Right? If we were coming up with an object about that same size, right, it would be about here on this ruler, but this would give me a measurement of just 12 centimeters, right? Going up by 10, so I need to estimate to the ones place, right? And 12.3 would be here, but we know that for certain with this ruler, so we need to estimate one more digit more specific. This will be 12.30 centimeters. Okay, so that is why B is our correct answer. All right, so let's turn the page, and you'll see it's flipped horizontally, but we have the power of 10 number line. So when I'm talking about getting more specific or lower, right, we're going in this direction. Let's make that arrow nice and pretty. So every time you are estimating, whatever your interval is, let's say your interval is 10 centimeters, right, you must be estimating to the ones place. If your interval is 0.01 centimeters, your measurement must be estimated to the thousandths place. Right, so you can always come back to this number line if you need to figure out how many decimal places or digits you should have in your measurement. All right, so just to wrap things up here, and then to introduce something that we call a meniscus. So in order to measure correctly, you must first determine the interval. of an instrument. Okay, so that's the first thing you should always do is figure out what your interval is. Once that interval is determined, right, move one decimal place that is more specific. Then the interval, right? And that's what you are going to record your measurement to. And then do not forget your units. All right, so take a second. Well, actually, before we do that, I need to introduce what the meniscus is, right? So you might notice when we're using a graduated cylinder to measure the volume of a liquid that it doesn't give us a straight line, right? You'll start to notice a curvature. We call that curvature, right, a meniscus, right? Spelled the same way as your kneecap, which is also called your meniscus, right? And we are going to always, right, measure the bottom of the meniscus. Okay, you might even see an inverted meniscus if we have something like mercury. You will still measure from whatever the lowest point of that meniscus is. So if I'm looking here, right, at this example, you want to measure from the lowest spot. So why don't you take a second, record the interval, what digit you're going to measure to, and then what your final measurement is going to be. Alrighty, welcome back. So our interval here, we are going up by 1, and then our units, I don't know if you got this, right, but it's a graduated cylinder, so our unit should be milliliters, right, lowercase m, capital L. You are going to then measure to the 10th place, or the 0.1 milliliters. All right. Now, this measure to, right, might also be called your precision. Right, and you will see assignments later on in the week where you're asked for the precision of the instrument. And because that's what we measure to, we say you're allowed to be wrong, right? Plus or minus one of your precision. So the precision here would be, right, plus or minus 0.1 milliliters. And then our final measurement, right? I see we have 45, 46, 47, 0.0 milliliters. Alrighty. All right, I hinted earlier about the tricky zero scenario, so let me show you this. We might have the same measurement with different devices, and we know which one is more specific, but it might be difficult to show that. So if we tried to take the measurement of both of these, assume that our units are milliliters, right? Our interval on the left, we're going up by 100 milliliters, so we need to estimate to the tens place. So we will call this 20 milliliters. All right. Now, right here, we're going up by the tens place. Okay. And we need to estimate to the ones place. Right. That would also be 20 milliliters. Right. We can't put 0.0 because our interval is not going up by ones. So how can we show that we have more confidence in this measurement than we have in this measurement? Right? So what we're going to do is we're going to, whatever that 0 is here, that was an estimated number, you will represent that by putting a line over the top of it. Right? In the past, that might have meant that something was repeating, but in chemistry and measuring, it's going to show that that is a significant number. So let me show you a quick example. If you can turn to page 8. All right, we got to do this pretty quickly because I only have 50 seconds left on my video. All right, so a good example would be B right here. So this arrow is right on the line of 300, right? Our interval is going up by 100, but so we need to estimate to the tens place. So our measurement will be 300 centimeters, right? But the 0 that we estimated to, which was the tens place, should get the line over the top. Okay. If we had something that might have gone, so let's say we had another letter that came to right here, right? Maybe this was D. This would be 60 with a line over it, centimeters, because we have to estimate to the ones place. So finish this, and then